Hey everyone, 7.6. This is screencast notes for practice that we'll have next class. So just I want to go through a couple examples that you can use when you start the practice. So example A, without graphing, find the x-intercepts and the y-intercept for the graph of each equation. So here, for example A, remember x-intercepts are found when y equals 0, and y-intercepts are found when x equals 0. So using that, we're just going to use the equation and plug in one or the other depending on what we're looking for. So if we're looking for x-intercepts, then I'm going to take the equation y equals negative 0.25 times x plus 1.5 times x plus 6, and I'm going to set y equal to 0. So I'm just going to go, okay, so then y is 0. Sorry for that little interruption. So 0 in for y equals negative 0.25 times x plus 1.5 times x plus 6. And when we're in factored form and equal to 0, what do we use to solve, everybody? The ZPP. So first one, negative 0.25 equals 0, not possible, so we just cross that out. X plus 1.5 equal to 0, x plus 6 equal to 0. Solve these, minus 1.5, so x equals negative 1.5, and minus 6. So x equals negative 6. So your x-intercepts are negative 1.5 and negative 6. So our x-intercepts we're going to write, you would have negative 1.5, 0, and negative 6, 0. And this would be the solution for our x-intercepts. So write them as ordered pairs because x-intercepts are coordinate points. Okay? So now on to y-intercepts. So pause if you need to. I'm going to erase so that I can keep that note up there at the top, even though I'm going to have a red line through it, which you know is going to bother me. But I'm going to keep it anyway. Ugh, okay. So now I look for the y-intercept. So remember, y-intercept, we set x equal to 0. So again, I'm going to take that equation, y equals negative 0.25 times x plus 1.5 times x plus 6. But this time, everywhere I see an x, I'm going to put a 0. So I have y equals negative 0.25 times 0 plus 1.5 times 0 plus 6, which simplifies down to just negative 0.25 times 1.5 times 6. So y is equal to negative 2.25. So my y-intercept, x is 0, y is negative 2.25. And there's your y-intercept. Okay? If you want to, pause and try 2 on your own, and then come back and we'll do it. You can check your work. Now's the time to pause. Okay, example A, number 2. Okay, so here's the equation, y equals 5x times x plus 3 squared, whoa, times x minus 3. Okay, so same idea. If I want to find x-intercepts first, y has to equal 0. So 0 equals 5x times x plus 3 squared times x minus 3. If it makes you feel better and you don't like that squared up here, what does squared mean? Well, it means you have that parenthesis twice, right? So x plus 3 times x plus 3, and then the x minus 3 on the end. So once again, I'm in completely factored form. It's equal to 0, so we use ZPP. So 5x could equal 0, x plus 3 could equal 0. This is the same thing, so that's the same as that. And this is x minus 3 equals 0. So you don't have to write this out twice because it is the exact same thing. It'll give you the same answer. But if it makes you feel better because you don't like that squared and it looks weird, go ahead and do it. So you have to solve all of these. Divide by 5, x equals 0. Subtract 3, x equals negative 3. Add 3, x equals positive 3. So this should tell you right away that you have a cubic function because we have 3 sets of zeros. So what are your x-intercepts? Your final answer, 0, 0, negative 3, 0, and 3, 0. So here are our x-intercepts. Okay? Once again, if you need to, pause because I'm going to erase so that I can do the y's. All right, so y-intercept. Once again, y-intercept where x equals 0. So y equals 5 times 0 times x plus 3 squared times x minus 3. Oh, how about I'm supposed to put in zeros for x. Hello. Okay, so 0 and 0. Okay. So what do we get? Y equals 0 times 3 times negative 3. And anything times 0 is 0, so y equals 0. So what's our y-intercept? 0, 0. Okay? So that's example A. On to example B. So example B asks you to use the graph of each function to determine factored form. So you see I put the graphs on there. So on to B, let me grab the graph that we need. Okay, so here we go. So you're using the graph of this function, y equals x squared minus x minus 2. That's our graph, y equals x squared minus x minus 2. That's the equation. And you're using the graph to determine factored form. So remember, factored form in this graph, what type of graph is this? Hopefully you have answered. It is quadratic, which means we have 2 roots. Okay, so in this quadratic graph, we would have a times x minus root 1 times x minus root 2. So I'm just going to start out with my roots. Here's one root, that's negative 1. Here's the other root at 2. So I'm going to go ahead and plug those in. So I'll have y equals a times x minus negative 1 times x minus 2. You know minus and negative becomes addition, so I'm just going to change that. And now the other thing is to find a. Well, to find a, you have to use another point on your graph. So I just look for another point. It seems like this could be one right here. So that is 3, 4. So I'm going to use that point 3, 4. 3 would be x, 4 would be y. And I'm going to plug it into the equation. So here I would put 4 equals a times 3 plus 1 times 3 minus 2. So I'd get 4 equals a times 4 times 1. So 4 equals a times 4. And then to solve for a, we divide both sides by 4. By 4. So a equals 1. So my final equation, I would take out the a, and in place of the a is a 1. And this would be the equation for that graph in factored form, without actually having to factor the general form. You can use a graph to do it. Okay? So let's look at something a little bit more complicated, like B. Okay, so B, hopefully you look at this. The equation that is given for B is y equals 4x to the third plus 8x squared minus 36. I don't know if I'm going to be able to write that in because it's stuck. 36x minus 72. That was interesting. I had to write that backwards. Okay, so that's the original equation. Here we have our graph, and I know it's really hard to see and probably really hard to count by, but we have our zeros. So our zeros here, this one is -3, this one there is -2, and this one over here is +3. Okay? So those are our zeros. This is, if you didn't already know, this is a cubic function because of the shape of the graph and the fact that we have 3 zeros. So, cubic function, factored form of a cubic function, y equals a, and it's the same thing, but instead of having only 2 roots for the quadratic, we just add in a third root for cubic. So I plug in the 3 numbers, so y equals a times x minus -3 times x minus -2 times x minus 3. Minus the negatives, go back, change those to pluses, and there is, hold on, I'll be back. All right, hey guys, I'm back. So I found out I could do this at school, but then I get interrupted by actually having to teach a class. So, so here I am. I don't know exactly where I left off. So we wrote our equation. We have a cubic function. We wrote it in factored form by plugging in our zeros. And now what's left is finding that value for a. So this was from the intro screencast. We talked about how to find the value from a. We have to find another point on our graph, and when I used the calculator to do this, I did find the y-intercept here to be 0 and -72. So we can use that point to plug in x and y, and we can find a. So we would have -72 equals a times 0 plus 3, 0 plus 2, and 0 minus 3. So -72 equals a times 3 times 2 times -3. So -72 equals a times -18. So divide by -18. And a equals 4. So our final equation would be written as y equals 4 times x plus 3 times x plus 2 times x minus 3. And there we go. Okay? So we converted from general form here into factored form by using the graph and the roots and then finding that value of a. Now, I don't know if you noticed, but in the first problem here, our value of a was 1, and in the second problem, our value of a is 4. So if we look at the original equation, what's the value of a in the original general equation? Well, a is always in front of x squared, so a is 1. Do you think it's a coincidence that a is also 1 when we solve the problem for a at the end? Probably not. Let's look at b. Again, we have a in front of the highest value of x, so x cubed is the highest value of x, so a is 4. And when we solve for a, we also got 4. So if you know the general form of the equation, then you can use the graph to find factored form, and you can kind of skip over this stuff here, because if you locate a in the original problem, then it's the same when you write it in factored form. So you can just take it right from there. So that's just a little bit of a shortcut. All right, so it's the quicker way to get a. If you want to write it down, I'll say it a little bit slower. Quicker way to get a. If given the function equation in general form, then a is the same as the number in front of the highest variable of x. So in this case, it's x cubed. In quadratic, it's x squared. In higher degree polynomials, whatever the highest degree of x is, the number in front of that will be your a. Okay? All right, so on your paper it says a little note. If you cannot determine the exact x-intercepts, or if the graph does not have any x-intercepts, then you can use the quadratic formula to find roots. So that brings us to our next example, example C. So example C says, write each polynomial as a product of factors. So that first graph, it looks like we can pretty much count those. So let me get that up here. All right, this is the first one. Okay, so we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I was just checking to make sure I'm counting correctly, that I was counting by ones. So this is 10, 10, how about I write it correctly? 10, 0, this point here, and this point here is 12, 0. So in this case, we don't have any issues. We have x-intercepts. We can count them just fine. They're right on those marks. So we have our two roots, root 1, root 2. So we can write the equation y equals a times x minus 10 times x minus 12. And then we figure out a. Again, we could pick a point on our graph, but we just learned that little shortcut. What's a in the original equation? A is 4, so in this equation, a will be 4. So y equals 4 times x minus 10 times x minus 12. And there's our solution. Nice and quick and easy. Okay, on to B. A little bit more difficult because, of course, everything can't be that easy. So when you look at B, here's where we run into a little bit of an issue, because I go to start out with that first step to find my x-intercepts, and I go to count and I see 1, 2, 3, and that line is in between 2 and 3. It looks like it might be 3.5, but you can't really tell on the graph. And then you look over here, 1, 2, 3, and again, that line is between 2 and 3, but now it looks closer to 3. So maybe it's 2.75, maybe it's 2.6, who can tell? So here is where you would have to use your quadratic formula to find your roots, because this graph is not as big of a help as the other ones we've been working with. So we set this equal to 0, and we can use the quadratic equation to find our roots. So we have a is 1, b is 0, c is 7. So we can plug that in. We would have negative 0 plus or minus the square root 0 squared minus 4 times 1 times 7 divided by 2 times 1. So I have plus or minus the square root of negative 28 divided by 2. So the square root of, oh, it's negative 7. Sorry guys, negative 7, positive 28. So the square root of 28 can be broken down. I'm just going to do a little sidebar over here. Square root of 28, 7 times 4. So 7 times 4. Square root of 4 is 2. So it's the square root of 7. Whoops. Square root of 7 times 2. So plus or minus the square root of 7 times 2 divided by 2. And then the 2 divided by 2 cancels. So we get plus or minus the square root of 7. So those are our roots, which means this root here is the square root of 7, 0, and this root here is the negative square root of 7, 0. Okay? Now you might have been saying, Mrs. Fallon, you can solve that equation by using square roots and inverse operations, and you would be right. So you could also, instead of quadratic formula, just added 7 to both sides, get x squared equals 7, and then take the square root of both sides, so x would equal plus or minus 7. And that's a lot shorter. The thing is, most of you go right to the quadratic formula, so I wanted to, go through how you would get it that way, and plus we get the little extra bonus of simplifying square roots. So anyway, so we find our two roots, and now we just have to put it in factored form. So remember, factored form, y equals, since this is quadratic, it just has two roots, so x minus root 1, x minus root 2. And it's really not difficult, even though it looks kind of silly. Let me change this color. I don't really like it. Oh, I love orange, but I don't like the way it's looking on here. Let's try blue. Okay, so we would get y equals, you know what? I'm just going back to yellow. Okay, so y equals a, remember a is 1, times x minus, our first root is negative square root of 7, and x minus, our second root, is positive square root of 7. The negative square root of 7 and the minus is going to change to a plus, and that's our solution. There's no simplifying. We don't want decimals. We want exact answers, so square root of 7 is an exact answer. All right, I'll leave you to read the notes there on the bottom. That just kind of goes over the same thing that I was talking about for example C. And when I see you in class, we'll do a bunch of practice on all these problems. Make sure you got it.